Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I am dealing with thermodynamics, and in this lecture, this is lecture number 14. In this lecture I will explain you what is pressure volume work. How will you explain this? Okay, so you know that W is equal to force into displacement. Okay, now we have to explain it. How? So let us take one cylinder in which a gas is filled. This is piston. A gas is filled inside this. So this would be initial volume V1, that is called initial volume, and it is called initial state. You know, this gas will always try to lift this piston. That is because of the force, and we consider this as a pressure. So to maintain the pressure or to make it equal pressure, we will put certain weights on this, which represent external pressure. So this will represent external pressure. So we call it P external. Okay. It is initial state. So P external would be actual pressure required on piston to bring it down. Or to make it stationary in the initial condition. Okay. So this is the condition. Now V1 would be initial pressure, initial volume. Now, if expansion of gas takes place, then this piston will move upward. We are not changing pressure because of certain reactions inside this cylinder. Due to that reaction, number of moles increased, and that is why piston move upward without changing pressure. So volume increased. Okay, we are not changing pressure, so pressure would be the same, and that is P external. It is the same. But now the gas expanded, and now we have gas everywhere. So this would be the final volume, V2. Okay, this is the final state, and therefore V2 will be a final volume. And as expansion of gas takes place, it is clear that V2 will be greater than V1, and therefore delta V, which is equal to V2 minus V1, will be positive. Okay, now let us understand this and write something about this expansion of gas. So the pressure which is basically force per unit area of the gas P exerts a force on the piston. This can be balanced. This can be balanced by applying an equal. This can be balanced by applying an equal but opposite pressure, from outside on the piston. Let it be P external. So P external is a pressure from outside, that is, we put weights on this to maintain the pressure. Now, if the gas expand at constant pressure, the piston would move through a distance, we call it L. How will you show it here? See, this is L. This is L. So this much distance is traveled by piston due to expansion of the gas, and that is called L. Okay. Now force is equal to pressure into area, where A is area of piston. Therefore, W is equal to minus P external into area into L. Since A into L is equal to change in volume delta V, therefore we can say W is equal to minus P external into delta V. Okay, here negative sign is kept conventionally. Okay, now there are two types of things, two types of work done by the system or work done on the system. So first of all, let us take expansion. First of all, expansion of gas, which I have shown you. So when expansion of gas takes place, that means piston move upward by gases. Piston move upward by system. So this is known as work done by the system. That means gas is doing work. So work done by the system. This is the interpretation of expansion of gas. And when work done by the system, where final volume V2 will be always greater than V1, therefore delta V will be V2 minus V1, which is positive, and therefore W will be minus P external into delta V. If delta V is positive, W will be negative. So when work done by the system, W will be negative. That means W will be less than 0. Okay. So this is one of this type of work. Now second is when work done on the system, and that is contraction of gas or compression of gas. So contraction of gas. Here we will bring piston down. How can you bring piston down? When you apply pressure from external forces. Okay, so piston is brought down by applying external force. That means it is work done on the system. So this is one kind of work done on the system. And in this case, as contraction of gas takes place, that means delta V will be V2 minus V1, which will be negative. Why? Because V2 will be less than V1. Okay, now according to formula, W is equal to minus P external into delta V. As delta V is negative, this is negative, negative become positive. So here W will be positive. Okay, so delta V, W will be positive, means W is greater than 0. So here when work done on the system, W is positive. Work done by the system, W is negative. Okay, so this way we can explain this work accordingly. Okay, either work done on the system or work done by the system. That's it in this lecture. Thank you.